Hello, welcome back. This is Module 2 of the Python class. We're going to talk about for loops, while loops, do-while loops, and something that I did not mention on the website. It's called list comprehensions. They're very useful. I use them all the time. List comprehensions make your code significantly shorter, easier to read, all the good things that a programmer should be concerned about. So I've got my Module 2 Python script up here. What we're going to do first is we're going to talk about collections. Collections are an object type that we didn't talk about before. If you're familiar with other programming languages, they're very similar to arrays or lists. I think it actually is a list. Collection is kind of a more abstract way to refer to them. So we're going to make a collection of, we'll call them squares. So our collection of squares is empty. You denote a collection by these brackets. My pet peeve is when you call things the wrong thing. So these are braces, these are brackets, these are parentheses, that's pipe. So no need to call it a square bracket or a curly brace. You know, that's what you say to people that don't know what they're talking about. These are called brackets. They will forever be brackets. One nice thing about a collection is you're not bound to any sort of specific object type like you are in a C array. So if I were to make an example collection here, I can have a collection of the number 1, the number 3.14, and the word blah, and that works. I can actually print this collection out, and it's going to have all three of those things. That's not wrong at all syntactically. There are legitimate reasons why you might want different object types inside of a collection. So that is totally legal in Python. And to prove it, we're just going to run this thing. Module 2.py. Boom. There we go. I printed it out. I have 1, 3.14, and blah. So that's kind of neat. But so we're going to generate a collection of square numbers from, I don't know, 1 to 9. So we won't get into the triple digits. So there's two ways that we can do this. We're going to talk about the for loop originally. Okay. So we can do for x in range. So range is an internal Python function. You can reference it just like you can the print. You don't have to import anything, you don't have to include anything. One nice thing about Notepad++ is whenever you start using these built-in functions, as soon as you open up the parentheses, it's going to have a pop-up text, just like you were in some sort of, IDE that supports some other language. It's got the full definition of range. You can't see it on the screen right now, but it's got 2 arguments, a start and a stop. I don't like to call them a start and a stop. I like to call them the start and the number of elements you want to include in the range. So if I wanted to start at 1, and I want there to be, I want to go 1 through 9. Actually, we'll just start at 0. Start at 0 through 9. I'm going to need 10 elements, right? So if I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 elements. Good programmers always start counting at 0. You can also view it as this 10 is a non-inclusive stopping point. So I want to start at 0, and I want to go until I'm at 10 and then just quit. Don't include 10, but stop when we get there. So for x in range of 10, what we're going to do is we're going to say squares dot append. And if you notice, if you're typing this out, I really wish it would show it for you. But it has a nice, Notepad++ has a very nice GUI. When I start typing .ap, it says, oh, you want to do append. So append is a function for a list, right? So I can append numbers to a list. Now what I want to append to this list is x multiplied by itself. There's a few different ways to do it. I'm going to do multiply x by itself twice. Okay, so I'm going to take x times x boom, done. That's a square, right? So I'm going to append that. And what I'm going to do is I'm going to print my squares. And don't forget your parentheses. Alright, and we'll see what this does. Okay. And as you can see, I have a list. It should contain 10 items, or 9 items. Or, yeah, sorry, 10 items. 0, 1, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 items. Okay, yes, because 10. That's how many items we wanted in the list. Okay, so we went from 0 to 9. That's 10 items. So we say square of 0 is 0, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, 5 is 25, and so on and so on. So it worked. Alright. So that is a basic for loop that we've defined here. So let's do it differently. Let's make a little print statement here. Print building squares list with for loop. When you do the assignment, try to do something different. Don't generate a for loop that, you know, makes squares. You can do like some sort of Fibonacci number sequence, and if you don't know what I'm talking about, just look up popular number sequences. Try to make a loop that generates them. It's kind of fun. The Fibonacci one, that'd be pretty interesting. I don't think somebody just getting started could probably do that one. It's very non-trivial. You'd have to reference different objects previously and stuff. So what we're going to do is, now that we've built our square list with a for loop, we're going to reassign squares to be nothing, and we're going to print building squares list with list comprehension. Almost fits on one line, but okay. So what a list comprehension is going to do is it's going to be pretty much the same thing, except it's kind of like an internal iterator. You can think of it that way. It's going to take that for loop and reduce it to one line of code. If you're not comfortable with list comprehensions, for loops are fine, but list comprehensions are extremely useful. And you can have nested list comprehensions on one line, and it's relatively easy to read. You can have conditional operators inside of a list comprehension on one line, and it's still relatively easy to read. I would strongly recommend getting familiar with the list comprehension syntax. I don't know what happened upstairs, but my dogs are probably going crazy. Getting familiar with the list comprehension syntax, be comfortable using it, understand its power, and understand when to use it. Don't just go willy-nilly and start using them all over the place. So we're going to say squares, and we're still going to set it equal to a list or a collection, but we're going to populate this collection dynamically with essentially that for loop that we've done before. So we're going to say we want to take x squared, multiplied by itself, so square it for every x inside of the range of 0 to 10 again. So can you see how that's very similar to what we've defined before? So we're going to say for x in this range, do this. Pretty simple, right? Not that bad at all. Let's go ahead and print squares again. So now we should have our squares list generated twice. We're going to have some print lines saying how we're generating them each time, and it should be done. There we go. Lo and behold, those lists are exactly the same. So we built the squares list using a for loop. We built the squares list using a list comprehension. Now we're done. I want to show you some other features of a list comprehension, provided I know what I'm doing here. So I want to say print x for x in squares. Alright, I don't know if this is going to work. It's kind of off the fly here, but no, it's not going to work. Maybe if I did one of these things. We'll see. There we go. That's how you do it. So if you can see here, I've got the 0 through 81 there. So this is a list comprehension that just iterates through the objects we've already put in squares, and we're just going to print them all out on a single line. This is the most popular use of a list comprehension that I do. So what I'll normally have is I'll have this huge list of items, and I want to iterate through each one of those items. But normally, I'm a fairly object-oriented developer. So inside squares, I would have a squares object maybe, and then for each square in there, I would just say call x dot do this, right? And so it's going to call a method for each one of these objects, and then this method can have different aspects and things that it does as well. All right, so that's a for loop and a list comprehension. Okay. So we're going to take the same principle and apply it to a while loop and a do while loop. So let's set our squares back to nothing. And then we're going to say building a squares list with while loop. Okay. So what I'm going to do is I'll just say while, or reference another one for you guys, while the length of squares is less than 10. Okay, so that's what's going to cause this while loop to execute, is we want to build the same exact list. So we want to make sure we have the same 10 objects inside. So while it's less than 10, we're going to iterate through this thing. Not less than or equal to, less than. If we want to do less than or equal to, it'd have to be less than or equal to 9, because we want it to run on the 9th iteration. Okay. So right now the length of squares is 0. After I run through this, it'll be 1, and then 2, and then 3, and then whenever it has 10 objects in it, it'll be done. So we're going to say we need a counter too, don't we? So we know what we're doing. Or actually, we're going to get super clever. Squares dot append. We're just going to take the length of squares, multiply that by itself twice. Okay, that should be it. If you don't understand what's going on here, length actually returns an integer. So when squares has 0 objects in it, we're going to take the length, which is 0, square it, and then append it. Okay? So function statements evaluate inside to outside. So we're going to evaluate the length first in here. It'll return 0, square 0, and then append it. Then we're going to have one object in our list, 1. Okay? So then we're going to take the length of squares, 1, multiply it by itself, and append it. Now we have 2. Then we're going to take the length of squares, multiply it by itself, and append it, 3. So it's going to work. I think it's going to work. The only thing I'm questioning is my less than 10 thing. I think it may need to be less than or equal to 10 for a while loop. And then we're just going to print squares again. All right. Let's see what this does. It worked. All right. Genius. You guys are so smart. So we're going to build the squares list with a while loop 0, 1, 4, 9, 16, 25, 36, 49, 64, and 81. Like a champ. Like a champ. So the next thing that we're going to do is exercise a do while loop. With the example that I've chosen here, it's going to be less obvious the difference between a do while and a while. One thing that you want to take note of is a do while loop no matter what, will always execute at least once. Okay? So to demonstrate that, what I'm going to do is I'm not going to reset the squares again for now. So I'm going to say do, and then do while length of squares is less than 10. Okay? That's what I want to do. Oh no, are do while statements a thing? You guys may be off the hook. Huh. Alright, you guys lucked out. My poor Python foo has failed me. There is no such thing as a do while loop in Python, so if you haven't watched this video and you're trying to figure that out, yeah, that'll be funny. I'm actually not going to update the course content to reflect that. So this is essentially all of Module 2. Make sure you do something other than generating squares. You know, don't make a simple counter either. Do something clever, you know. It's up to you. Build a string if you want. I don't really care. There's you know, be creative. You're not being graded on actual content. You're being graded on your understanding, and the real point is to just understand the difference between a for loop, know when to use a for loop, a list comprehension, understand the syntax for a list comprehension. It's a little bit different. Understand a while loop, when you'd want to use any of these things. Don't burden yourself too much with trying to come up with something clever and neat. Just experiment with it and have fun. Most importantly, have fun. One thing that you might notice in the grading rubric that I've specified is that you need to have some sort of comments in your code that explain what it's doing. That way, whenever you submit me your amazing and creative script files that have all these neat functions and things going on, I can actually read it pretty easily. If you notice, I've named my variable other than x. X is kind of a lame name, but squares, pretty intuitive what it does. I probably should have said like squared numbers or something, but and as far as comments go, as long as you have print statements in, that's almost the same as a comment. I'll let a print statement slide. I use print statements a lot, especially when we start talking about different Python modules. We're going to talk about the logging module at some point. So instead of printing, we're going to log. We'll log to a file. We can log to standard out. We can log to standard error. But once you get to that point, commenting does become more important. Another thing that Python has is print line debugging. It's pretty useful. If you don't understand what's going on, just throw some print lines inside of your loops, inside of your functions, see where the code is flowing, and just have a lot of debugging and trace statements in there. It'll help you in the long run. I think that's all I need to talk about for Module 2, especially since the do while loop isn't even a thing. Jeez, I'm a knucklehead. I'm sorry, guys. But this was a pretty simple thing. Other than this line, this line of code's a little bit clever, and if you don't quite understand what the length function is doing, or the order of operations of function nesting, it could be a little complicated, but I have full faith that you guys will figure it out. Alright, till next week.